This lesson is on slope. Slope measures how fast one quantity changes with respect to the other. For example, you could think of the rate of 10.5 kilometers per hour as a slope between how far you're going versus how long you're taking to go there. If you continue along the same slope, you'll notice that you could also state it as 21 kilometers per 2 hours. That's just one example of slope. In general, slope is the ratio of rise to run. It's all about how much the dependent variable is changing to how much the independent variable is changing. So it describes the rate of change, which is vertical over the horizontal, and that's what slope is defined to be. So how do we find the slope of a line given 2 points? Well, let's check it out. Slope is defined to be the rise over the run. The rise component is created by looking at your y values, which in this case are 1 and 4. So what is the height here? You can see it's covering 3 spaces, which is the same as going 4 minus 1, giving us 3. So our rise is 3 units. Now to go over, you'd be looking at the x values, which are in our case 1 and 2. So to get from 1 to 2, you're stepping once 1 unit, so the run is actually 1 unit. And it can be found by looking at the x values, the difference between the x values, which is 2 minus 1, giving us 1. So in this case, this fraction, this ratio, simplifies to 3. So our slope is 3. In general, when you want to find the slope between 2 points, and notice point 1 will be labeled x1, y1 because it's point 1, and point 2 is labeled x2, y2 because it's point 2. Here's a general graph. So your x1, y1, say, is right here, and x2, y2 is right here. So you'll notice to find the rise, you need to find the change in the y values. So the change in the y values is going to be the difference of your y values. Now to find the run, you're going to be looking at the change in your x values, which is given by x2 minus x1. Boing! That is the formula for slope given 2 points. However, I would like to encourage you to really think of slope as rise over run, and then think about which components make it rise and which components make it run. So difference in y versus difference in x is more what you should really be focusing on. Let's give it a test run. Find the slope between these 2 points. So we've got the x and y components, x and y components. If you'd like to label it as point 1 and point 2, you may do so. So slope, labeled m, is the rise over the run. And the rise can be found by taking the difference in your y's. You could take your y2 minus your y1. You could also go the other way, y1 minus y2. As long as you're subtracting in the same order, you're going to be fine. So let's take the second minus the first. So negative 7 minus 5. And then let's do the same to find the run, 3 minus negative 2. Notice the points will be here, but the minus will be always in the middle. So sometimes you will have double signs. So we've got negative 7 minus 5, giving you negative 12, and 3 minus negative 2, giving us 3 plus 2, giving us 5. That can't simplify any further. We're done. That is our slope. Let's try the next one. Notice that they're asking us to find the slope between 3, negative 7 and negative 2, 5. Look back, it's exactly the same question, but let's see what happens if we follow with the formula. So the formula for slope tells us to take the second minus the first, so we're going to go 5 minus negative 7 over the difference of your x values, negative 2 minus 3, difference in your so that gives us 5 plus 7, 12, and negative 2 minus 3, negative 5. And that is exactly the same slope. So slope does not depend on the order of the points. And it also means that you could subtract them both this way, or you could subtract them both the other way. And that's fine, as long as you keep your rise on top and your run on the bottom. Let's try some more points. Find the slope between the following. So you've got your x and your y, your x and your y. Point 1, point 2. Let's find the slope. I'm just going to subtract the way that the formula tells us to. 2 minus 2 over 0 minus 3, giving us 0 over negative 3, giving us 0. A slope of 0. What could that possibly look like? Let's take a look at a graph and see what these 2 points form. 3, 2 is approximately here, 0, 2 is approximately here. So those 2 points are actually lying on a horizontal line. So imagine walking on a horizontal line. You would have no problem. There is no slope. Slope is 0. Let's take a look at the next example. This one here, we're going to take the slope and see what it gives us. 6 minus negative 2 and 3 minus 3. That's giving us 8 over 0. We cannot divide by 0. So what's that called? If you recall, that's called undefined. And what kind of line is that anyway? Well, 3, negative 2 and 3, 6. Why, that's a vertical line. So if you were trying to walk up that line, could you walk up that line? Well, no, it's completely vertical. It's impossible for us to walk up a vertical slope. Therefore, the slope is undefined. Horizontal lines have slope 0. Vertical lines have an undefined slope. Let's look at the following examples. Here we have an increasing line going up, going from left to right, and a decreasing line, which goes down, going from left to right. So here you're walking down, here you're walking up. Let's look at the slopes of the following points. Let's look at the slope let's take a look at the slope. So we have -3, -2, and 3, 2. Find the slope. That'll be 2 minus -2 will be the rise, which will be 4. And you'll see 3 minus -3, which will be 6, which is your run. So you'll notice that this is a positive 2 over positive 3 as a simplified fraction, which means you're going to have to go up 4 and right 6. Up, right. They're both positive. In the decreasing slope, let's take a look at these 2 points. We've got -2, 2 and 0, 1. The slope is, let's take 2 minus 1 and -2 minus 0, giving us 1 over -2. So what this is telling us is that we could go up 1 and left 2, or down 1 and right 2. Then notice the negative could be treated in one place but not both. So let's generalize here. You should be noticing that an increasing line has a positive slope and a decreasing line has a negative slope. You should also notice this important part here. This is the key that's going to let us use slope to our advantage. So whenever you look at the rise and the run, in the rise, if you decide a component is positive, it refers to going up, negative going down. Run, positive right, or negative left. So in this case, our slope was -1/2. You could treat that as -1 over 2 or 1 over -2. And notice you could treat it as going up 1, left 2, or down 1, right 2. Whereas in this case, our slope was 2/3, positive 2/3. So you could see yourself going up 2, right 3, up 2, right 3. You could also see it as 4, 6, up 4, right 6. So this is how we read and use slope. Let's take a look at an example where we have to read the slope based on what it's telling us. So in this example, they tell us the slope is -2/3, which could be either -2 over 3 or 2 over -3. Both are considered exactly the same as long as you don't make them both negatives. And this one could be read as down 2, right 3. This one could be read as up 2, left 3. And we know that it's passing through the point 1, 2. So let's check that out. 1, 2 starts here. Now let's follow our directions of the slope. The slope is telling us down 2, right 3, or up 2, left 3. Notice it's all on the same line. So this method is going to soon make it easier for us to graph linear equations.